Before I get into the mallet build, I thought I would talk a little bit about what I've been up to since my last video. My last video was building the footrest for the chair that I had just built, and that footrest used gears. And it was my intention at the time to design and build the mechanism from the 3D printed gears, but eventually to replace those with gears made from another material, either wood or metal, say aluminum. And to do that, I would want to set up my CNC. Now, we go back about 4 years, and Stepcraft sent me out one of their M1000 CNC machines, and I had it in my workshop set up on the wall. Well, actually on a table first, and I made the table, and then up on the wall, and I did a great number of small things with it. However, I was having problems with it, and that kind of limited what I wanted to do with it. But the long story short is I took it off the wall out in my shop with the intention of moving my shop to my small shed out in the backyard and downsizing stuff. And I moved the CNC into my basement where I am right now, my little editing bay, you could say. And that's right outside my laundry room where the CNC is set up right now. I took it down here, I mounted it up on the wall, and then right after that video, I started building the enclosure around that CNC. Now, before I did that, I started it up, I got it all hooked up, and I tested it to see if it was actually working, and it was. There were some small problems with it that I thought I could solve, okay? So I built the enclosure, and I set up the material in there to cut the first gear to test out. And I immediately started having problems that wouldn't go away. Or they might go away eventually if I did enough stuff. But at that time, my frustration level was building enough that I said to myself, what you really should do is take this CNC apart and rebuild it in a more, say, open source type way, where it's using, you know, a setup that I built from the beginning and I'm very familiar with, as opposed to the closed system that is the Step. Now, I'm not knocking Stepcraft and their machines. It's just that they're like a turnkey system that you really can't do anything with without support from them. And I'm not a support guy. I don't like going to look for support for anything. So what I did was I started taking it apart, and I immediately started to draw a plan that I could build from Baltic birch plywood mostly, and uses the large linear rails, linear bearings that I bought for the wall-mounted saw that I was going to build in my shed. This picture shows the beginnings of the machine, the base, which is 1/2-inch Baltic birch plywood, and the rails, which are 2 layers of 3/4-inch Baltic birch plywood capped with a 1/2-inch thick of white oak to give me a surface that is more friendly to hand planing. I actually checked it to make sure it was flat and hand planed any small places that needed adjustment. So I mounted the first linear bearing, and I made sure that was nice and straight and nice and flat. And I used that as a guide to mount the one on the other rail, except I had to get the gantry set up to do that. And the sides of the gantry are made from 3/4-inch Baltic birch plywood, and they mount right onto those linear bearing blocks. And as you can see in this picture, I also 3D printed mounting guides to make sure that those bearing blocks are lined up perfectly on that ledge that's mounted on the sides. And you might be asking, why didn't you just reuse the linear guides on the Y axis on the original machine? Well, this picture shows the difference between the linear bearings that I bought for that saw and the ones that are on the machine. The ones that are on the machine are very small, and they would be prone to binding. And that binding was one of the problems that I had with the original machine. So the next step was to get the X-rail mounted, and I'm just reusing the X-rail and the whole Z-axis assembly from the original machine. I didn't really make any changes there. I did make mounting plates for the ends, once again 3D printed. And what that allowed me to do was to line up that extrusion perfectly on those gantry sides. And as you've already seen, I've used 3D printed parts for a lot of things here, templates and mounting parts to line everything up, including the holder that holds the ball nut for the ball screws on the y-axis. These are made from ABS and they bolt directly to the gantry sides. And the ball nut fits inside there and is also held in place by screws. And I know it, you're saying that can't be strong enough because everybody else makes those things from metal. Well, I've been using the CNC ever since, and this is more than a month, and I've made several things and no signs of any problems with these 3D printed parts. And that includes my solution for replacing the couplers that link the ball screws to the motors. I replaced the motors on this new build, making them bigger, stronger, and also closed loop. And they have run perfectly, no problems. But the coupler, I made that from ABS again, 3D printed again, and the shaft fits on the ball screw, which is 12 millimeters, and the other end fits on the new motor, which has an 8 millimeter shaft, as opposed to the old motors, which had a 1/4 inch shaft. And here you can see how these are made. I printed the body vertically, and to reinforce it, I actually printed holes in it for finish nails that go through and act almost like rebar to reinforce the plastic. A big difference between this build and the original machine was that I wanted everything out in the open so that I could easily get to it and easily maintain it. That includes linear bearings, ball screws, and also the limit switches. And in this picture, you can see that I actually made housings for the limit switches so that they'd be easier to mount. And I also 3D printed the brackets that trigger those limit switches. And to organize the wiring on the Z-axis and keep it in place, I actually designed and printed wire mold for those wires to fit in. Eventually, I got to the point where I had everything installed, ready to test. And here I've got it hooked up to my laptop where I'm running Mach 3. And you can see the breakout board that I'm using, just one of those cheaper ones, and the closed loop stepper motor controller beside it. More 3D printed parts to organize all of these wires that are coming out of this thing. And then I could move it down into my basement, because prior to this, I was doing all of this work in my kitchen, on my kitchen island, move it into that cabinet and get it set up there. After I got the controller all hooked up, and yes, I'm leaving it out in the open like that, I got the bed slats put on. These are the originals from the original machine and have those very handy aluminum T-slots. And then I ran the surfacing bit over it to flatten it. The next thing that I did was I made sure that the X-axis is square to the Y-axis. And the way to do that and make it as accurate as you possibly can is to use the 3-4-5 method. This is something all carpenters, and I'm a carpenter, know about, and it's where you can take the numbers 3, 4, and 5 and create a very precise right angle. In my case, I went up 30 inches from the home position and then over 22.5, and the hypotenuse between those 2 points is 37.5. But to measure that precisely, what I did was I used a 1/8 inch end mill to actually drill holes in the bed at that 30-inch height up, and then I put an end mill in that hole, and I cut a strip of wood to a very precise 37 3/8 of an inch. That's 1/2 inch minus an eighth, with this half of the diameter of the end mills. I left the 1/8 inch end mill in the spindle and I moved it over to the 22.5 inch, and I put the stick in between, and I adjusted, after unplugging all of the controllers, that is, all the motors, I adjusted the motor, the ball screw on that side until I got that stick precisely in between those 2 end mills. And that means that the axis is as square as it possibly can be. And of course, I'm going to save that stick. It's actually inside the enclosure, and I'll use that again if I need to. So with all that done, I went on to making some parts on the CNC. And in this picture here, you can see I'm actually milling a short shaft, the hex end of it, so that it will fit in one of the gears for my chair. Then I started milling out some of the gears that I need, and the machine worked perfectly. These gears are exactly the size that I printed them to. And one of the exercises here, or the objectives here, was to make this so that I could do all of this, design the part, print the part if I want it, or CNC the part using the FreeCAD program. I learned to use FreeCAD several months ago to get better at 3D printing, and it has a section in there for CAM work, and I learned how to use that in the meantime as well. And here you can see some of the parts that I made, and here they are mounted on the chair, and here are some of the other parts that I made to finish it off. So obviously the CNC works well for wood, but what about other materials like plastic or aluminum? I want to be able to mill aluminum on this as well. And so I set up what I call a waiting pool inside the CNC machine. And it's just a box with sides on it and sealed so that it contains the cutting of the aluminum inside the box that's mounted directly onto the spoil board. And that way it doesn't, pollute the rest of the CNC with coolant. Because when you're cutting aluminum, you really want to try to use some kind of coolant. And in my case, I'm using a spray bottle with soapy water. That's all. This is a piece of 1/8 inch aluminum that I've cut into a 5x5 square, and I'm milling holes in there as well. And this is for another CNC project that I've got coming up. Successfully cutting the aluminum made me think that maybe I should try cutting steel as well. So I got a piece of 1/8 inch mild steel, and I put it in my waiting pool again, and I tried milling that. And to be honest, it actually cut better than the aluminum. I made 4 tabs that are actually washers from the 1/8 inch steel. So now that you know what I've been doing, I can move on to the mallet build. And no surprise that I'm going to be doing the majority of the work on the CNC. Here I've got a piece of hard maple that is about 1 inch thick. I'm going to cut it to length for the 2 parts of the mallet head. And I also have a scrap piece of oak that I'm going to be making the handle from. I'm going to cut that to width, and then I'm going to cut both parts down to a rough thickness just to get them close to what they're supposed to be. Then I can bring the parts down to my CNC machine where I can conveniently wash clothes as well and get the blank for the mallet head clamped down. And this first operation is for flattening the surface. And then I can flip it over and start milling the slots. And what are these slots for, you might say? Well, that's where the spare change comes in. I actually have a lot of nickels and dimes that I don't spend because they're virtually worth nothing these days. And I'm going to put them inside this mallet as the weights for a dead blow. And of course, the idea for dead blow is that there's loose weight inside the mallet. And what it does is it counteracts any rebound that happens after you strike the hammer. So after the slots are cut, I did a profile pass around the outside, and then I cleaned out the dovetail area where the handle attaches. And once again, I did all this cam work with FreeCAD, programming all of the tool paths. After I cut the slots, I moved the material again and I surfaced that side with the 3/4 inch bit. Then I loaded the blank for the handle and I got that cut out as well. And as you can see, there's a dovetail shape on the end of the handle that fits into the head and that locks it in place. Rather than using tabs to hold the parts in place, I didn't cut full depth. I left about a 1/16 of an inch. So I'll bring it out to the shop and I'll cut through that on the bandsaw. Then I put a flush trim bit in my router table to cut off that excess. This is the full sheet sandpaper holder, a project from a couple of years ago. And the sandpaper that's in there has gotten pretty dull, so I want to change it out. And here you can see how the dovetail on the handle fits into the dovetail slot in the head. Now, of course, I could have left everything square, but it will be a lot more comfortable to use the hammer if it has rounded edges. So I changed to a round over bit in the router table, and I'm going to do this in 2 passes, so I won't risk having a tear out. And you might also notice that I'm doing this with a climb cut, and that also helps prevent tear out. So a little hand sanding on the handle and also those slots in the head, because I just use a 1/4 inch end mill on those. And I want to get the nickels in there to make sure that they fit and that the slots are actually deep enough. And luckily they are, so I can load in the rest along with all of these dimes. And sorry, I'm not using any polyurethane construction adhesive on this project, even though it would work. I want to get this glued up and done quickly, so I'm using regular wood glue. Now, one concern I had was that the glue might squeeze into those slots and glue the dimes and nickels in place. So after I had this clamped up, what I did was I kept shaking it to make sure that nothing stuck. So I let it dry overnight, and then I brought it back down to the CNC, clamped it in place so that I could do some branding. This is a 1/16 inch bit, and I'm cutting it in 2 passes, although I'm only showing the first one here. And then after it's done, I can give a light sanding to get rid of the woolies, and then bring it back out to the shop and do the final sanding on my homemade belt sander, and also a bunch of hand sanding. And this is what it sounds like when you shake it. And yes, the blow does seem quite dead. So once again, I could have left it as it is, but I decided that I wanted to make it a little bit darker. So I got out my stain mix with polyurethane and I wiped that on and wiped it off, just to darken it up a bit and make the lettering stand out a bit more. And then the first job with the new mallet is to fasten the lid on the can of stain. Anyway, so that's the update and the project. I hope you enjoyed it, and I'll see you next time.